Hello everyone, it's me Amna and welcome to Amna's Learning Hub. I hope you all are fine and finding my videos helpful. As we started organic chemistry, I uploaded my first lecture and today we are moving towards the second lecture. In first lecture, I gave you a brief introduction about organic chemistry. Then I told you about different functional groups and the definition of functional group, that how it works. Today, we are going to see the general formulas of different functional groups and homologous series and a few concepts about organic chemistry. Let's start. First of all, title, organic chemistry. If you can recall that, so organic chemistry was the chemistry in which we deal with the study of compounds which are extracted from plants and animals. Initially it was believed that, but now organic chemistry is the branch of chemistry or the chemistry in which we study about the compounds which have carbon, hydrogen compulsory and then have oxygen, nitrogen, sulfur and so many other atoms or elements in them. So in organic chemistry, in today's lecture we are going to study about homologous series, then we will talk about alkanes, alkenes, alkynes. Basically, the general formula of all of these compounds. And after that, we will talk about isomerism. And we will also talk about catenation. So our today's agenda will be homologous series, alkanes, alkenes and alkynes and their general formula, isomerism and catenation. So let's start with homologous series. That what is a homologous series? Homologous series is basically a series in which there is a sequence of its members. It is like a family in which there is a sequence of the members and every one member is different from other member. The difference between one to another member is of CH2 in the case of alkane, alkene and alkyne. So homologous series is basically a series in which all the organic compounds are arranging themselves. In every homologous series have a specific functional group, and that specific functional group, the all members of that particular functional group have a sequence. For example, in the case of alkane, every one compound is different from the other compound. The difference between those two compounds is CH2. So if we know one compound of any homologous series, for let's say alkane, you can identify all of the next compounds and their names. For example, I am talking about alkane and the smallest alkane that we have is methane, which is CH4. If I add CH2 in it, next compound will be C2H6. If I add CH2 again, next compound will be C3H8. The next one will be C4H10. So CH2 is representing us the whole series. So this series is known as homologous series. I hope this point is clear to you all. Next, if I talk about alkenes, and we will apply the same CH2 formula. So first alkene that we have is C2H4. Then we add CH2, it will be C3H6. Then we add CH2, next one will be C4H8, right? So this is the formula of alkenes and this is how we can find out the next alkene. So homologous series tells us about the sequence of the compounds in a particular family or in a particular functional group. I hope this point is clear to you all. let's study about the properties of homologous series. There are a few properties of homologous series. First one will be each homologous series have same functional group. That means if you are talking about alkanes or you're talking about the homologous series of alkanes, so every single compound will have the same functional group. Second, they all will have same chemical properties. Third, they all will have a sequentially increasing or changing physical properties. Now what this means? This means that we have so many physical properties. We have melting point, we have boiling point, we have density, we have so many other properties. So if I talk about melting point, with the increase of the formula of compound or with the increase of the size of the compound, melting point will be increasing. So sequentially increase, like the methane is a gas and it will have least melting point. Then we will have ethane, propane, butane. As the size is increasing of the compounds, so the melting point is increasing. That means from lower to higher, when we are moving, melting point is increasing, boiling point is increasing, and density is going to increase as well. So this is the this is the concept of homologous series. Same is the case with other. So the most important properties of homologous series were same functional group, same chemical properties, and sequentially increasing or changing physical properties. Next thing that we are going to study today is general formula. We are going to discuss about the general formula of some important compounds. For example, today I am going to tell you about the general formula of alkane, alkene, and alkyne. In O-levels syllabus, there is no alkyne, but the concept is somehow related to alkene because it is having a triple bond and it is having a double bond, right? So general formula of alkane will be CnH2n plus 2. General formula of alkene will be CnH2n. And general formula of alkyne will be CnH2n minus 2. That means n is any number. It can be 1, 2, 3, 4. So if we know the number of carbon or we simply put the number of carbon, we can find out the whole compound. For example, let's suppose I am saying carbon will be 4. So carbon will be 4, C4, H2 into 4 plus 2. So that means C4, H10 will be the compound. So just knowing the number of carbons, you can find out the whole compound. You can find out the number of hydrogens, you can find out the number of oxygens and so many other things if you are following the particular compound. Next is alkene. Let's say N will be 3. So C3 H3 into 2 into 3 because it's 2N. 2 into 3. So C3 H6 will be the compound. So if you know the general formula of any compound, you can find out the number of hydrogens and you can find out the whole compound of that particular number. Next will be alkyne. Let's suppose I am assuming that N will be 6. That means C6 H2 into 6 minus 2. So C6 H10. 6 to the 12 minus 10. So it is C6H10. So this is how we will find out the formula. Every compound, every class, every homologous series will have a general formula. As we will move on, I will tell you the general formula of alcohol, the general formula of carboxylic acid, the general formula of ester, and so many more things. So till here, I am describing you the general formula of alkane, alkene, and alkyne. Alkane's general formula is CnH2n plus 2. Alkene will be CnH2n and alkyne will be CnH2n minus 2. I hope these three formula are clear to you all. If you have any question, drop your comment or message me on Instagram. I will answer you promptly, inshallah. Next, a very important concept that I am going to give you is the difference between saturated and unsaturated compound. In organic chemistry, we have organic compounds, and those organic compounds are classified into two classes. One is saturated compounds and others are unsaturated compounds. So keep this thing in your mind. The saturated compounds are those compounds which have only single covalent bond in them. For example, alkane, for example, haloalkane, or anything in which we will have only one covalent bond, only single covalent bond throughout the compound is known as saturated compound. If I talk about unsaturated compound, it will have either double covalent bond or triple covalent bond. So if any compound has all the single covalent bonds, that is a saturated compound. If any compound has any one, even one double bond or even one triple bond, it will be categorized into an unsaturated compound. For example, all sort of oils that we are extracting from the plants, or we are extracting from any other thing, all kind of oils, even cooking oil, everything is lying in the saturated compounds. And if I talk about ghee or solid kind of oils, like we're talking about desi ghee or we're talking about banaspati ghee, so all of those are unsaturated compounds. Even the coconut oil, because that is thick or that is solid, that is in unsaturated, that is unsaturated compound. So this is how I just gave you a few examples of saturated or unsaturated compounds. So whenever we talk about alkane, alkenes and alkynes, it is very important to discuss about saturated or unsaturated compounds. I hope this concept is also clear to you all. Next concept is very, very, very important, and most of the questions come from that section. Okay, that section seems very easy, but whenever we want to apply that concept, it seems a bit confusing. The topic is isomerism. First thing to memorize is the definition of this. Isomerism is any compound that have same molecular formula but different structural formula. Keep this thing in your mind that anything, any compound, any group of compounds which will have same molecular formula but different structural formula, these are called isomers of each other, and this is the method is called isomerization. The method through which all of the compounds are formed is called isomerization, and these are called isomers of each other, and this property of organic compound is known as isomerism. For example, we have a compound C5H12, right? Now this is an alkane. If I draw the structure 1, 2, 3, 4 and 5, and each carbon can form only 4 covalent bonds, so every carbon will be attached with 4 other things. So I am attaching hydrogens with it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. This is the compound which have 5 carbons, and if any compound has 5 carbons, that means it is a pentane. In previous lecture I told you meth, eth, pro, but, pent, hex, hept, oct, non and dec. All of these were the counting of organic chemistry. These were the prefixes that we use that will identify us the number of carbons, and after that I told you some suffixes in which this one has ane, that means it is an alkane. Now this compound is pentane, and this structure that I drew is the extended structural formula or skeleton formula. So let's draw expanded molecular formula. CH3, CH2, CH2, CH2 and CH3. This is called N-pentane. Next one will be CH3, C, CH3, CH2, CH3. This is CH. This is called isopentane. And third one is C, CH3, CH3, CH3 and CH3. I told you that every carbon can form only 4 covalent bond. In this case, every carbon is making 4 covalent bond. In this case and in this case. This is called N-pentane, isopentane, and this one will be called as neopentane. Right? Now, all of these, if you count the number of carbons and hydrogens in all of these compounds, it will be same. Like in this case, 1, 2, 3, 4 and 5 carbons, and 3, 6, 9 and 12 hydrogens, right? In this case, 1, 2, 3, 4 and 5 carbons, 3, 2, 5, 6 and 3, 9 and 3, 12 hydrogens. And in this case, 1, 2, 3, 4 and 5 carbons, and then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. So all of these compounds have same molecular formula. This is C5H12, but different structural formula, different structural arrangement. This type of process is known as isomerization, and the compounds are isomers to each other. So one compound has different compounds have different isomers, and even compounds have millions of isomers of them. Isomers have some restrictions as well, like the sequence must not be same, the compound the number of carbon on which substituent attached will not be same. The words that I'm talking about, I will make another video in which there will be a nomenclature in which I will tell you how to write the names of the compounds, how to understand that which sort of compound is this. So this is called isomerization, and this concept is very important. I will make another separate video on this concept, that is isomerization of organic compounds. Next, a very simple definition of catenation. It is just basically the property of organic chemistry or the property of organic compound. It's very basic and simple definition, that is catenation. So, catenation. If I talk about the definition of catenation, very simple, very easy, that is ability of carbon to make long chains. This ability of carbon to make long chains is known as catenation. You just have seen that in pentane, carbon makes a long chain of 5 carbon. Even carbon can make a long chain of even 1000 carbons. We will study that in polymerization. So the ability of carbon to make long chain is known as catenation, and catenation can only happen in organic chemistry, because only in organic chemistry carbon can make long chains. So whenever the word catenation comes, the thing that must come in your mind is the carbon's ability to make long chain. So in today's lecture, we talked about homologous series, which is very important. Then we talked about isomerization, the very important topic. Then we talked about the general formula, and then we talked about the catenation. I hope the lecture was helpful for you. I hope you will learn organic chemistry in a better way. So stay tuned, stay connected, see the lectures, and if you have any problem, do ask me questions on Instagram or on my YouTube channel. You can comment down on YouTube, or you can directly message me on Instagram. I hope it will help you a lot. Thank you so much. Take care of yourself. Allah Hafiz.